speed. So if you see speed with max-min problems, you should be scared. The second one is loudness. When you see loudness with max-min problems, you should also be scared. Everything else is actually stock standard. Once you get used to it, they've all got work already. Yeah. What was I saying? Sorry, hold on. Loudness, hard. Speed, hard. When you see those, don't run away from them. Tackle them head on. Because this one right here was in this year's Catholic trial paper. So whoever would have done the Catholic exam, CWSA papers, this was the question I was asked. And it's obviously in my booklet, so there's no excuse why any of the students that came here couldn't have done it. It's very simple. So don't run away from it, even though it looks hard. Now there is a difference between the speed and the loudness question, and I call them I and double I. So there's always going to be a part I, which is to make your formula, and then part double I, which is to actually differentiate and find the nature, right? With loudness, part I is easy, part double I is hard. With speed, part I is hard, to actually get it is hard. Part double I, the differentiating bit, is easy. But like I said, just when you see what I'm about to do right now, don't be scared of it. Tackle it head on. I told the Thursday kids that just passed, I told them, you know what your hand just needs? Just to repeat it like 3 times. Literally, so repeat this exact question 3 times for your hand to just get used to the letterings and stuff like that. It's hard because there's no numbers. For those who are good with algebra, you're going to find this pretty straightforward. It's just hard because of the algebraic expression. Don't forget this is an advanced topic, so for those who are doing extension, which is you guys, it's usually okay because you've done extension stuff. So let's do it anyways. The noise level, N, at a distance d meters from a single sound source of loudness L is given by this formula. Fair enough. 2 sound sources of loudness L1 and L2 are placed m meters apart. Yep, I think we can see that. They're m meters apart. There's P, which is x meters away from L1, which means what about this? What is that? What would that distance be straight away? M minus x. Right? So if that's x, that would be m minus x. And obviously the whole thing is m. The point P lies on the line between the sound sources and is x meters from the sound source of loudness L1, which means it is m minus x meters away from L2. Write down a formula for the sum of the noise levels at P in terms of x. Okay, sounds complicated, but N, the noise levels here, so N equals L1 over, what's D? D is your distance, which is what? L1 over x squared. It's the distance away. D is the distance, D meters from a single sound source of loudness L. So it's however meters away from L, which is L1 in this case, plus what? What would the sum be? Plus L what? L2 over m minus x squared. Good work. That's it, done. That's part I. That is the sum of the noise levels, isn't it? Because the noise levels N, the noise levels N, which is L over D squared. L is your loudness, which is L1. D is your distance away from L1 or L2 respectively. Simple? So like I said, if doing I is easy, double I is going to be hard. Or harder. Double I. There is a point on the line between the sound sources, blah, 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 blah. The reason why I say that is because that's how you have to read it. You know it's a max-min problem, so you know the steps. Step 1, I've got to find my stat point, which means y dash technically equals 0. Step 2, I've got to find its nature. There is no points of inflections. There's no such thing for points of inflections for max-min problems. So that's all you stop, you're done. You already know the steps. Right? You don't need to read it. Let's just start it. dn on dx. Don't write n dash Get comfortable with it writing like this. We only write dashes for y's. All right, equals. What do I do before I even start actually with this? Before I can start, why do I stop and go, okay, I have to do something to the top one? What am I going to write that as? Okay, well, can you differentiate this? You can? How?
You need to make the common denominator.
Say that again, sorry, Emily? Yeah, that's what I mean. So that's what you've got to do first. So I can't differentiate it like this. I've got to change it to L1 x negative 2 plus L2 m minus x negative 2. True? Now I can differentiate. You said common denominator. You're going to introduce it as a quotient rule after that. You don't want to do that. You shouldn't. If it's already been split, just bring it up. Okay, now differentiate. So negative 2 L1 x negative 3 minus 2 L2 m minus x negative 3 times the derivative of the inside. Don't forget your chain rule. Yes? Agree? All right, then don't forget, what are we going to make this whole thing equal to? What is that equal to? 0. So then eventually I've got to solve. So we're not going to leave it like this. We want to make sure we do what Anouk probably just said, which is eventually a common denominator or something like that. So let's have a look. Negative 2 L1 on x cubed plus 2 L2 on m minus x cubed. For those of you that are writing in the booklet, there's still lines to take on the next page. So don't feel like you got to squeeze it in. Okay, equals to 0. Obviously, you'll bring everything to one side. Oh, sorry, you'll bring one of them to one side, just easier to multiply like that, and leave the other one in there as a fraction. So 2L2 on, let's just say, I'll leave it like this. It's up to you. If you had done common denominators at this stage, it's fine. It would work out exactly the same. So don't say I wouldn't have done that. It's fine. But that's what I would have done. Well, then at this stage, I just cross multiply instead of thinking of common denominators. 2L2 x cubed equals 2L1 m minus x cubed. All right, little problem. I've got x on two sides, which we don't have usually, and I've got this binomial expansion that's going to occur. But then I think about it, I'm like, whoa, to do a binomial expansion, I'm going to have x cubed, x squared, x, and then a constant, and then to bring everything to one side, and then the only way I can solve a cubic like that is polynomials. True? And then I think about, wait, but polynomials is 3 unit, I mean 2 unit, so that means it's wrong. So stop thinking like that. You see, so it's okay to think, and then when you run through it before you start, you're like, oh yeah, not going to work. So what am I going to do? Instead of expanding, what's the other thing you can do when you're at this stage? Common factor. You can't. There's nothing that is common actually. What else? What's annoying you? And then fix the problem. What's annoying you? Well, what do you think is annoying me when I see this? I think that cubed. So how are you going to fix it? Because everything else you shouldn't be looking at, like 2L2, 2L1, your eyes shouldn't even be there. It should just be on that cube. That cube's annoying because I just told you it can't be a binomial expansion. So what are you going to do? How do you get rid of a cube? Yes, say it. Cube root. Done. We're going to cube root this thing. So it's going to look like this. Cube root 2L2x equals cube root 2L1 m minus x. Hey, look, I've got a power of 1 now. Now I can, what am I going to do with this number and this bracket? What are you going to do? Number, bracket. Faster, Neda. What would you do? You would expand. Yeah, you got to see these as numbers. So this looks like this: 3x equals, I don't know, 4m minus x. I need to solve for x. You're going to see how quick you saw that? Don't look at this. Don't look at this. All you should be looking at is a number. Just think of it as a number, picture as a number, and then m minus x. I'm trying to bring x to one side. So don't forget that. You're trying to get x to one side. So that becomes cube root 2L1 m minus cube root 2L1 x. What do you do at this stage? I'm just putting these little things at the end. That tells me that that x is not attached inside my square root. My surd completes there. So if you ever see me do that, it's just for myself, so I know that m is not inside, it's on the outside. Maybe some of you should be doing it as well. It's good technique. Anyways, what would you do now? Emily, what do you reckon? What do you reckon? What's my next step? Remember, you're solving for x. Don't lose track of what you're trying to do. What are you going to do? Make x the subject, so that right-hand side x, one on your right-hand side, what are you going to do? Bring it to the left-hand side, right? So this guy is going to get added to this. It's going to look like this. Cube root 2L2x plus cube root 2L1x. We're almost there. And factorize divide. Finished. It's in terms of L1, L2, and M, as the question would have already stated. Now can we go grab your booklet now? Yeah. And you see what I meant by your hands just got to get used to it. So you guys just got to repeat this so that you learn, oh yeah, at this stage I should have expanded. At this stage I should have brought the x over. It's just because there's a lot of algebra. It looks bad, doesn't it? But when I've broken it down like that, you're like, oh, it kind of makes sense. It's what you should have done if I gave it to you with numbers. So if you feel like that's the case, do what I just did before, make numbers up, tell yourself what would I have done, and then repeat it for this question. Okay, we're done with stationary points. What do we still have to do now? Nature. All right, here we go, nature. Nature. There's two methods, y dash table, which you're going to be silly, because what's the left of this? Right? What the heck is that? You can't do that. And what's the right of that? So you're not going to do nature through that. You have to do nature through y double dash. So let's have a look at it. Let's go up. Where was it? Let me just make a shot of that. That was y dash. Y dash equals to that. So fix it up again. Negative 2L1 x negative 3 plus 2L2 m negative x negative 3. All right, we're up to nature, Novak, of this. You might as well continue in your book and then copy it later on, because it's going to be good. I said you should copy it down anyways, so your hand gets used to it. So, nature, we're going to do y double dash. There's our y dash from before, and let's do y double dash now. Y double dash is positive 6 L1 x negative 4 minus 6 L2 m minus x negative 4 times, don't forget, derivative of inside, negative 1. Fix it up, looks like this, 6L1 on x plus 6L2 on, boom. Sounds good? Any questions? That was okay, right? Let's go up before we go back to this. Let's go up. What are we trying to prove? We're trying to prove it's a minimum. So what do we want for y double dash for it to be a minimum? Greater than 0. All right, let's think about this. L1, L2, and M are all positive numbers because they're loudness. Loudness is positive, and M is distance. So you know what? L1, L2, and M. L1, L2, M greater than 0. What about x to the power of 4? Always greater. And what about anything to the power of 4? It doesn't matter. So you know what? X to the 4 and m minus x to the 4 is always greater than 0. Therefore, y double dash is greater than 0. Concluded. Therefore, min. Before you finish it off, what did we always say? Go back and reread the question. Make sure you've answered it. I think the question just said to find x, but let's make sure. Find an expression for x, yeah, which we've done. Sometimes it might say actually find the noise level where it's minimum. So you got to sub x back in, but that would be too crazy. So it has never been asked, but just saying. For other questions like area. Done. That wasn't too bad. I told you the hardest bit of it is that y dash, that's the algebra there. If you can get your head around that, you're looking good. Loudness. I's easy, double I's hard. This was not a band 6 question. I think you know that. It's more of a 9900 question. So it's not just band 6, it's talking about the highest of the band 6s. So 99 and 100. So that's how you got to think if you want to get to the 99 level. Sound good? Okay. Let's move on. We'll do this. And I think we're pretty much done. There's only 2 more left, right? And then there's primitives, which I'm not going to do because that's part of integration. We're just going to do that on the integration. It'll take me 2 seconds. Okay. Well, I'm going to stop here because this one's not that difficult in geometry. So I'm just going to pause. We'll open up this year's paper. So let's stop the recording for a second.